All right, welcome to another coding session. Continuing with Bangalang, we went through we did a big refactor in the last session. It took us a while, but we got there. And I was just running our playground and I realized something. The first loop does 0 to 9 correctly, but the second loop actually does 2, 4, 4, 8. I don't know how I didn't catch this before, because I rolled back a couple of commits. Well, I rolled back to here, I guess, where we first did the range-based for loops, and it also had this issue. So today I want to do some more refactoring. I want to extract out, data type annotations. I want them to be their own member of the node instead of being part of the children, which I talked about before. But before we get to that, I want to nail down what the deal is with this. And with something like this, where I'm actually I don't really know what could be the issue. It's really hard to kind of rationalize what it could be. So I'm going to have a look at the assembly, and we're going to go through the assembly and see if we can find anything that doesn't look right. So let's go to this loop. We should see this allocation pretty easily because it'll be assigning 2, 4, 6, 8, or it'll be assigning some floats. Here it is, float 0, 1, 2, 3. So let's look from here onwards and see if there's anything that doesn't look right in here. So let's start with this guy. So, well, that's part of that for loop, I think, this deallocation. So, I mean, there's immediately something wrong with this, but that's for another day. The fact that we allocate twice and then we copy these values in, which looks legit, and then we copy, basically we copy from this allocation to this allocation, and then we deallocate this. It's a waste of time. I know, we'll fix it later. Then we have this allocation. I mean, it all looks right. I mean, it looks weird, but it looks right to me. Then we have this allocation, which is really simple. It's an 8-byte allocation, which has been assigned 0. So that'll be we don't have it actually explicitly here, but it'll be the index of the current element that we're looping through. And then we do this, so this should be, it's grabbing that index, putting it in a register, comparing it with 4, which I guess is the length, and checking that it's less than that. And if it's not less, then we end the loop, so that all looks good. Now the first statement within the loop will be, we actually inject a statement. If we go to our ranged for, it is this case here. So these are all the basic for, the 3 parts of the basic for loop. And then there's this element assignment that we inject into the scope at index 0. So this is declaring a variable. It's basically declaring value and assigning it foo, like foo0, foo1, foo2, foo3, and the different iterations. So it's creating a new variable. And actually what I immediately notice, because I just said it's declaring a new variable, when we declare a new variable on the stack, we should get an allocation. That should be the first thing. But if I double click on this allocate, like everywhere where we allocate, there should be the comment allocate. And there's no allocation in here. So why is there no allocation? So this is our assignment, and this is where we check what allocator it is and do the allocation. So we should be doing this allocation, but it seems like we are not. So what is it? It's called value. Let's put a little if no.value equals value. Whoops. Just like always. Can't have a video without screwing that up. If we do something like that and break there, we don't break there. Did I do this wrong? Oh, left-hand side node. Okay, so we're in a basic for, because during type checking, both of these will get converted to basic for loops. So we're here, we're looking at value and we allocate it. So I guess that's here, that's this first loop, right? So if we skip to the next one, are there any other statements that have, it's this element node, right? So for, this is the second type of for loop, that's this kind of for loop. It looks like it only appears once in this assignment that we inject. Here it appears more times. So it actually appears twice in assignments on the left-hand side. So this assignment might actually be the plus equals, is it? If we go, so the operator node, yeah, it's add a sign. Okay, so that's this guy here. If we step again, so now we're basic for, so we're in the scope of a basic for, and we're assigning to value. So this sounds like I said, the thing that gets injected into this one. So this is the one we're interested in, and it jumps over. What's the condition here? We're checking if it's a declaration, and the way we do it is it's an identifier that's not a member, and it's in here, but this, so I think this is the problem. It's in here because I used to sort of keep track of this more diligently, but then I thought, oh, it doesn't really matter if we just keep maintaining the same list. And then if we come across a new variable with the same name, we'll just override the old one when we insert it into here. But what I didn't think about was that actually this is a problem. Because it's never going to allocate. Okay, wow, that's actually a pretty big issue with my code. So I think we're going to need to do, like with our context, we're going to do what we do with type checking, which is copying our context. And this is actually out of date because it doesn't copy these, it doesn't copy this. And this next index, if we copy the type checking context and then we update this, then when we go back to the parent context, we should copy that back. So we're actually doing a shitty job of handling the context and type checking as well. Okay. I think a safer way could be to just like create a copy of the context, so they should handle all those things. These, it's going to do a shallow copy of this. So I might just go like that, so clear it in the copy and then do a manual copy across, so that it's, so this is effectively doing a deep copy of the identifiers, and we'll do the same thing with the out of order identifiers. That should be better. And now in the generation context, I want to do the same kind of thing, and stack variable offsets is the map that we need to deep copy. Everything else is fine. Path doesn't need to have a deep copy. And so here, when we do this, we need to be careful that we take care of next index and also output. When we go back to the parent context, we need to make sure that these have been updated in the parent context. So let's start with type checking. I feel like that's the correct order of things to do. So where do we actually copy? Basic for ranged, I don't think we, because here we actually, in the end, we do a basic for. So I feel like, yeah, and this is not actually used anywhere, so this is pointless. So let's get rid of that. This for loop, okay. So when we finish, what did I say we need to take care of? This, I think it's just this next index for type checking that we need to copy back. Otherwise we're going to get, we can potentially get duplicate labels. So right at the end, let's go context.nextIndex equals for context.nextIndex. And for the scope, we do the same thing. Okay, I think that should be type checking sorted. Well, let's get rid of this. For the generation, I guess we need to do it in the same place. For GLSL, it doesn't matter because we don't even use this stuff. We don't use the indexes, we don't use this, like, yeah, it's not a big deal. We don't use the for index. .for index. Yeah, it looks like it's only used in x86. Okay. Yeah, so we don't need to worry in GLSL. So here we want to go to our basic for, and for context is, I guess it's generation dot copy gen context. I guess we could just say copy context, because now that we're in the different separate packages, it's not really necessary to specify gen here. Actually, let's do that. I think that'll be nice. Just copy context, and in type checking, we can just say copy context. Previously, when we didn't have these separate packages, there was name conflicts, but not anymore. Okay, so basic for, we create this this for context. So I think we don't need this anymore. We can just go like that. And initial for index, which looks like we revert, but context. But if we never actually update for index in this context, then that's all good. I'm just going to replace a lot of these. Yeah, and a lot of them are going to need this. There we go. So context, this context should only be used at the top and the very bottom, which looks right. So then what did we say we need to keep track of? The next index and the output, I think. So we'll copy that back and we'll copy that back. Okay, I think that takes care of it. And this 4 index, because we only set it inside here, we don't need to revert that anymore. We used to, but we don't need to. Cool. And the other place is the scope. So we make a copy of the context, and this time let's call it scope context. And everywhere where we use the context, we use the scope context. This can be context.stack size. So we don't need this. Maybe I'll move this after and we'll do like the same thing we did here. Should be the same. Oops. Same lines basically, except we say scope context to clean up. Okay. With a with a bit of luck. Okay. Now we get our 2468. And if we look at the assembly, we get an allocation. That's what we wanted. Okay. All right. So that was a bit of an aside. I just realized I haven't started my timer. We're at 17 minutes already, just to fix up that mess. And now we're going to get stuck back into some some refactoring. So get ready. Here we go. We're adding a data type. All right. We mentioned this before. This is going to enable a bunch of features, like these 2 features that will help with. I think with some other features, it's also going to help disambiguates, like, because previously a child node would one of the data type annotation would have been one of the children, but then it gets confusing because, well, what if we legitimately want a type to be a child in the main flow of the program? Then it gets confusing. Is it a data annotation or is it really a child? So this disambiguates. Okay. So we have these utils. We have, where is it? Somewhere we have get type. Here we go. So we don't, this is assuming that the type is the last child node, which is not anymore. So let's do a search for get type. We're going to do regex. So get type, and I guess we need to escape these brackets. And then I'm going to put a group in here. And that's going to be one or more A to Z underscore, could be one of these brackets, could be a dot. I feel like that probably covers most cases. And then we're going to replace that with $1. Okay, I love it how it gives this example. It's really good. So node dot data type. That's what it should be. Replace. So now we should not need get type. Okay. Because I did it with AST dot. If we take off AST dot, replace those. I'm a little bit surprised. Why is it not matching that? We also need 0 to 9. Okay, so let's do that with AST dot first to make sure we get rid of that. And then we'll do it without AST dot. There we go. Okay. I just want to find where we use is type and make sure it still makes sense. For type alias, we need to make sure the right-hand side is a type. That makes sense. For static procedure, we're making sure that the left-hand side is not a type. But we're also checking the left-hand side as a static procedure. And if the left-hand side is a type, then its data type will be nil. Types don't have data types. Doesn't make sense. So I think we can just cut this off. Is type is recursive. We don't want to generate type aliases. That's right. Okay. Yep. This is saying that the call is actually a conversion, type conversion, which we don't support yet in GLSL. Generate primary. So this I want to get to later, but we're going to leave this on for now. Can't generate a type alias, that makes sense. This is also the generate call, so this is how we do it in x86. This is that same condition we saw before. So basically this is saying like it's a primary, so if we have an expression and we're looking through the expression, we find a type, we ignore it, we don't process that. We want to fix that later because we do want to process types, but right now we don't. I hate this stuff. This contains allocations. It's ugly. So I think what this is looking for is a swizzle. I'm looking for a swizzle, remember? I think we might have to, I think I'll leave this one in for now. I'm really not sure about this one. Let's take that one out and see. No, let's leave it in. Because I don't want to break stuff. Type checker call, so we're checking if it's a type, so that means it's a conversion. That's good. Types are visible in nested scopes, yes. This is that same condition we saw before. I've just been opening so many files and not closing them. This is where we resolve types, so this is necessary. This is also resolve types. And when we're converting an SRA index, we ignore types. Yeah, I'm kind of being on the cautious side, but I just wanted to check if there was any obvious places where they should get removed. I also want to find anywhere where it's like, you know, dot type equals dot type. That might seem like a weird search. But anyway, that's kind of like a more manual check. It's like is type as well, but it's like more, it's not quite as flexible. Let's just have a quick look through to see if there's any of these that don't make any sense. No, this is all in type stuff, so I'm expecting that to be fine. Is type, yeah, of course, it needs to check. It's just a guard. Yeah, parsing a primary does different things. This is actually a different kind of type. Okay, happy with that. What about not equals? So we're generating a call, going through the parameters, and going through as long as there are more children, and as long as the next child is not a type. So I think this we can get rid of. I think this is because the type was the last child, this is preventing us from processing that type as a parameter, which is what a lot of the other children are in this case. We don't need to check that anymore because it's not possible for it to be a type. And this is the same thing in x86. And this is also looks the same. Okay, so we can cut those off. Okay, so now we are properly referencing data types, but we are not assigning to those data types anywhere. We need to, instead of adding a data type to the children, we need to now actually set it as the data type. So I kind of want to have a look. So type primary, everywhere where we find type primary should be this type primary is what we want to put in the data type, basically. So it's recursive, obviously, that's not a big deal. Left-hand side declaration. So when we're parsing our left-hand side declaration, here's the type stuff. So see, instead of appending the type node there, we should set the data type to be that. Or we set it to be none. I think that's it for that. So let's set the data type there correctly. Oh, we can see here where the matches are. So struct type and procedure type. The return type, because it's part of a type already, should actually be appended like normal. So that one doesn't need to change. Within the struct type, these are actually identifier nodes with type information. So this is annotating this. So for struct types, yeah, for each member, we should say member node dot data type equals, and I think I'll just put this directly on here, like so. Okay, I think that's parsing figured out. So now type check, let's do type checking. Oh, I didn't realize that was actually scope to type checking. Oh no, probably only just did that because we had that selected. Okay, so for type checking, I want to search for append. So, and then I want to kind of look for all of these and see whether they make sense. So immediately here, this is a type node. So we're referencing, so we're creating a type node, which is a reference to the original data type. So it makes sense to append this data type to this other data type. But then when we apply it to the node, we should do that. I have a feeling there's going to be quite a few more in here. Yeah, like this one. Should be like that. It's probably more like that. Yeah, this one's exactly the same. This one we take the child. This seems to be applying a type. Child data type. Yeah, it's applying a type. Let's just open this file and look for append in here. So this one we looked at before, it was all good. This is also creating a type node, and then interestingly, it's like clobbering the original type node, which I don't like. I think it would be better to make a new pointer and just replace the old pointer, because of that original type node. I mean, I guess in this case it's a clone, so it doesn't matter. But just in general, I like this better, because what if the data type that was already there is like, because some data type nodes are reused in a lot of places, and we don't want to clobber or anything like that. So I think this is just a nicer convention to use. These are all data types that we're adding. Cool. This should also be the data type. We're overriding the data type with none if it's untyped. So that simplified that a little bit. That's a little bit cleaner. Let's see, I guess that's enough for that one for now. I want to look in type checking. Let's have a look in here. I think this is going to be a bit complicated too. This is the call. We found it's a type, so this is saying that it's a conversion. So it's like this, you know, if we're calling a procedure, but that procedure is a type, then it's a conversion. I think this is applying a data type. So the return type, so the data type of a call is the return type of the thing that it's calling, the procedure that it's calling, which in the case of a conversion is this type. So I think this is applying a data type. I'm not sure if this clone is necessary, but let's leave it. Don't want to tempt fate. So I feel like this is the procedure type node. So here we can see this is an identifier, one of the parameters, and then we were adding to its children this data type. But I think now we'll put it here. Apart from that, and then when we apply it to the procedure node, that's also applying the data type to the procedure, like so. Okay, what else we got here? This is also applying the type to the call. like I said, the type of the call is the type of the return type of the procedure it's calling. And this is how you get the return type of a procedure type. So hopefully that's enough there. Import identifier node. A module, that's a type. Type module. Ah, this, okay, I see what this is. This is the globals, and this is that special thing that we added so that the import procedure gets its return type. So if this is the import procedure, we actually want the data type of that procedure, and we add to that the module. Yeah, that's the return type. Okay, cool. Next. This is clone, that's fine. That's a path. Left-hand side. Path stuff, path stuff. Border names. Ah, that's right. Let's go to type checking so it's a little more limited. Okay, I think this is a type node. And it's a reference to this, so we want to go node, oops. Node.data type is that. And here node.data type is that. This is a type node, it looks like. I don't know if we need to dereference this actually, because it's a pointer. That's tempting fate a little bit, but hopefully that works. And then I believe this is setting the data type of that. This whole procedure still feels a little dodgy to me, but hopefully that works. New node. Yeah, I don't see any type stuff there. That's path stuff. That's not a type. Another new node. Oh, here's a data type, it looks like. Looks like it's being added to this guy here, so I think we could just say, this is kind of nice actually. I'll put it here so we can just go like that. It's kind of nice how we can do that and get rid of a line. Okay. So that's an assignment. It doesn't look like, oh no, this is what we just were looking at. This one I must have just removed. This is path stuff. It's the queue. This is assigning a data type to the left-hand side. It's taking the data type from the right-hand side and applying it to the left-hand side. Like so. Again, we're kind of clobbering this type node, which I'm kind of not so thrilled about. Yeah, I don't really like that. In a lot of places now we have these really pointless assignments like this. I think here I'm going to get rid of it because I think it's going to make things a bit clearer. I should really have a list of incomplete types. that I can just easily search through, because there's a couple of places where we need that. So when we substitute this in, I feel like it's going to make things a bit clearer. Is there anywhere else where it's needed? Lots of places. Hopefully that's about it. But anyway, here, so I think now if I just go make node, then again I can just like replace it instead of clobbering it. What's wrong with that? Probably need to do that. Okay, all right, on to the next one. Operator node, that should be fine. Here, these are identifiers that we're adding. Number literal, no type stuff there. Assignment, identifier, assign, allocator, identifier, assign, length. I think this is all good. That's a number literal, allocator. Okay, so this is a type node. But again, this is the identifier. Oh, we've already done this one, it looks like. Okay, this looks like we're applying a type node to this guy. This probably also, yeah, looks like it. That's also applying type. That's path stuff. This one looks like it's already done. That looks like a data type. What is this? Module. Ah, yes, so this is when we're resolving an identifier. So there's probably a couple of those. This is applying data type to this. This is the other identifier node one, yeah. Where are we here? Type check swizzle member. This totally looks like it's applying the type information. And this also. Cool. What is this? Member type node. New member type node. Just an array with a type. Looks fine. I guess this is applying the type to it. Like so. This, yeah, I'm gonna get rid of, I mean, eventually I think I want to get rid of like all of those because they feel really pointless. So let's just use once. It's just an easy refactor. That looks like another clobber. That looks like another clobber. And it is a pointer, like we're making it this. Okay, I think again here I'm gonna say, I'm gonna get rid of this. I can do like a replace in here. Crazy. So node.data type. I'm going to check them one by one because there might be some, yeah, like this one should not be. Okay. All of that so we can do that. So we don't clobber, we just replace. Okay. That's right, we've done this now. Oh, that's the same place. Type node, new type node, add member node. Ah, yeah, because the type node is like a, is it like a struct or something? Yeah, it's a struct, so it should have members which are identifiers with type information. Yeah, which is what we've got here. Okay, next, this one looks like it's already done. That one also looks already done. This looks like our ranged for loop stuff. So here it looks like we're adding type information to this guy. So I guess the easiest way is to go data type equals. So these are not types, no types, no types. Here's the type. Let's just go down to there. Or is it a bit further? Here, this is we're adding a type to element node. Yeah, element node is one we get from parsing basically. So let's do this. Any other types? No, 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 nope. Down here, we add a none type to this guy. No types. No types. That sure looks like a type. Yeah, that's for compound literals. We add the data type there. That sure looks like a type. Coerce type node, that really looks like a type. It's links. Looks like some sort of string stuff, nothing to do with us. Also string stuff, and that's it. Okay, so that's type checking. Let's have a look in generation. There's only 20 in here, so I think there will be not much. These are like names and things. This here, static var node, I don't see any type stuff here. Path stuff, static var node. This one does have type information. It actually looks like a complex kind of array type node. Maybe if we put this up here, and say the type node equals this array thing. Which we add the element type and the length. Makes sense? And then down here, we add that data type to the static variable. Okay. It's path stuff. Path stuff. Comparison. Looks like there is a type node. It's the third child of a comparison. So I think it's actually adding a type to this node. So I think we can just go data type equals. I guess it needs that for this generate expression to work properly. It needs to know what the type of expression it is. Yeah, that makes sense. Okay. Literal values. Okay, that was the end. Let's try and run our playground. Okay, we have an error. This must be somewhere where I substituted like this. And I missed one. Not bad that I only missed one. Okay, all right, now we get into the tricky part. So what surprises me here is that string is actually an alias data type, so it should not show up here. Aliases get resolved right up front, so you should never see an alias in an error message. That's actually something I want to change. It would be nice if you could see the aliases in error messages, but right now you can't. So why do we see it here? So that makes me think that a type is not being resolved properly. If we go to types, there's like resolve types. Yeah, resolve types. Why would this not? So resolve types goes recursively through everything, and I'm just noticing it goes recursively into the children of the node, but it's not going to the data type of the node, which is where a lot of type information, a lot of type identifiers reside now. So I think we should say, like, if there's a data type, then we should recurse this stuff here I think doesn't really apply. It's like if we find a type and then we go up a node and we see like, oh, we thought we were indexing this thing, but actually we're declaring an array or a slice. Since we're just going into a data type, that doesn't really apply, I don't think. So I think we can just do that. And that should handle the data type. Okay. We're getting somewhere. So playground 6, it's like types are not compatible. Compound literal must contain 4 elements. That's interesting. That's the length of the array and the number of children. We're cutting off the last child because the last child was a type, but it's not anymore, so we can just use the children directly. Is there anywhere else that we do that? this is just cutting quotes off of a string. So is this. That's getting the last child, that's fine. Here's another compound literal thing. And we're cutting off the last child. Let's undo that. Here we're getting the last child. Again, we're cutting off. This is more compound literal stuff. We're cutting off the last child. I'm not sure if I'm catching everything because this window is small, but we'll get an error if I miss something. Param node from type. I think that's legit. This is some string stuff. Oh, this is the interpreter. This is a different project. Okay, I think I called all of those. Oh, I missed one. Should be node.children, right? Let me double check that. Yeah. Okay, that took care of that one, but we still have this error in a couple of places. U8 and U8 slice are not compatible. 6 and 10, I guess it's this here. Somehow we're getting incorrect type information. So let's have a look. I think it'll be this one here. So the type node is U8. So that one's wrong, I think. The expected type node is a slice of U8. Yeah, so the expected type node is correct. The actual type node is wrong. What are we calling here? Procedure node. Oh, that's right, we're calling I to A, of course. So why would that data type? Is it this data type? That's not very helpful. No, that's the expected data type, so that one's correct. This one is wrong. Param node is wrong. Param node is one of this node's children. So param node would start without type information, right? I think. And it would gain type information through this. Upgrade types. I don't think this is the issue right now, but I think this is an issue. So I think we need to actually be looking at the data type. Like this recursively goes through children, but what we're actually caring about is the type annotations. So if the new type is any string and the old one was also any string, then we upgrade and we don't have to do a shallow copy now. And if the data type, see this is the other place where we use these incomplete types. Was any incomplete type, then we upgrade it also. I think that fixes that. I don't think that actually fixes our current issue. The current issue I'm a little bit confused about, actually. So why would this, I guess this is when we are slicing. And it seems like when we are slicing, we're getting the wrong type information back. So that's primary index. This is when we're slicing. I think this is it. Yeah, so it's giving us just the element type instead of a slice type, because this length of children that we use to detect whether it's a slice is the wrong number of children. It should be 3, because it was including the data type child, because we just added it. I wonder if it makes more sense actually to say, like, if there was 2 children, we do this. Otherwise, we do the other one. I don't think it needs to happen up here. I guess we'll find out. Because now we clone it, but actually we wanted to clone this, I guess. Do we need to clone here? I'm really not sure that that's needed. I don't know, maybe I'm being silly, but I don't think we really need to clone. Sometimes it just crashes. I don't know why, like this is hasn't even gone into my code as far as I can tell. Okay. So this is grabbing a type node, but it doesn't look like it's grabbing a data type. So procedure type node, this is parameters. This is getting the first parameter and the data type of the first parameter. That was an easy one, I think, if that worked. Oh, we're back here again. Let's get rid of a bunch of this stuff. So what's the issue now? We go to convert, but the source type node is probably like null or something. It's any number. So is it the parameter? The parameter is any number. The return type is I64. And this is a conversion. So let's go to type checking of call. Go back to our conversion code, which seems to be still wrong. So here's our parameter. We do type check it, but we don't expect anything. So if it is any number, it's not going to get upgraded. Can we expect something? I don't think we should, because that will enforce. No, we can't, because we can't enforce a specific type for a parameter. That doesn't make any sense for conversion. And then we're checking if it's numerical And that's all we do. So I think we need to upgrade. And what would we upgrade to? I was going to say I64, but they could put a float literal in there, in which case we want to upgrade it to F64, I think. So if we have any float, then we should upgrade it to F64. Otherwise, we should upgrade it to I64. Now, this is kind of assuming that it's just going to be number types. I mean, we are checking down here that it should be a number type. So maybe we'll put this down here after we've established that it's a number type. But if we expand to conversion of things that aren't number types, this will need to be changed. But I think that's fine for now. Let's see if that works. Looks like it still didn't work. Still says any number. Grade types, param node. The param node has a data type, which it should, and should be like any number or any float or something. Then we update the data type and we go recursive. I don't really see why that didn't work. So if param node data type is any number, let's step in. Whoa, do not want to step into these crazy procedures. There we go. So it's not null. It should go into here, and the new data type is I64. So we upgrade it to I64, right? There's no children. So param node as a number literal I64. Am I missing something? Like why? But maybe this procedure type information hasn't picked that up. Param type node. Ah, okay. It's these pointless assignments that are tripping us up. We go like that. Okay, now we have a different error. We looked at this before. We're assuming it has a children, and it does not. I guess we could do that before because it would at least have a type child. Which is why we checked that. So can we check that instead? Okay. Somehow I was expecting more errors to show up, but it's working. So let's try running the test suite. Maybe we're not getting errors because it was just a simple example. So far, so good. Okay, the test suite ran fine. OpenGL, a more complex example, did not like it. Oh, it does like it. It's just like sometimes it crashes trying to get the name of the program. Okay, it's going very slowly. Oh, we have a couple of rogue windows. So everything's happy? Crazy. Okay, that was a successful refactor, I feel like. We're not quite at an hour yet, and I want to tempt fate and try and do some of these. This is like the first feature that we can implement using this new refactor. Let's be smart and do a whip commit, just in case. Okay, so let's do a size member. So like what I want to do is I should be able to go i64.size, and that should give me the size of an i64. Makes sense? So for type checking, so this is where type checking primary, this condition we saw earlier, meant that when we're, like this is an expression, right? And so this is a primary within the expression. And it will come to this first, and then it'll be like, okay, I want to look at my children, and it'll come to this, and it'll be like, I don't really want to look at that. But I think I want to take that off now. Although when we do come across a type, there's nothing to do. But it's valid for a type to be there. So I feel like that's a nicer way to have it. And then also a generation of a primary. We can take this off. And I guess in GLSL also, if you come across a type, we're not going to print anything out. So maybe I didn't need to remove this from that condition, but I don't know, it feels nicer without it there. Like it feels like the type node is included now. It's not being excluded. Good old type node. But again, yeah, I'm just going to return nothing because there's no, like this should return a memory location or like some sort of location, but the type has no location, so I'm just going to return empty. So maybe that was all pointless, but whatever. So now back in type checking, the next thing I want to look at is identifier. If our identifier is a member, and the child node is what it's a member of, so if it's a member of a type, so for example, this is a member of a type, so we can say if node.value equals size, we need to apply some type information. We'll call it an i64, the size. How does this work? We just have like if else to prevent it from going into other paths. So I think we'll go like else. It doesn't make sense to auto dereference the member of a type. Whoa. what happened there? Let's try that again. Why won't you format? There's something wrong here. I'm missing a brace. Oh, I don't know how that got deleted. Okay, now it formats nicely. And I think we need to have an else actually. Else is not a member of type. But now we're really saying it's not a member of type, so I think we need to kind of differentiate a variable with type. So the variable name would be, I guess it's child node dot value. Which we don't have. Now we do. So this error message is for not a member of type, for when we have a variable, not a member of module. Okay. So up here, I can say, if you try to access a member that's not size on a type, it's not a member of type. Yeah. Okay. So this should pass type checking now, but if we go like size if, oh, I was like, why did it work? Because we're running the wrong thing. Size if has not been declared. Huh. Size if has not been declared. Okay. So it's gone into this else. Right, as member is assuming that you can only be a member of an identifier. I'm going to say that you can be a member of a type as well and hope that that doesn't break stuff. I'm not sure if that's going to break stuff. Okay, size F is not a member of I64. Cool. But if we do size, then we get a crash probably or something. What is a crash? Generation? Yeah. We're back here again. Because now the child can be a type? Yeah, now the child can be a type again. Okay. We're going really backwards and forwards with this. So now we want to check, make sure that the first child is not a type. Okay, and now we're in generate identifiers. This is where we actually need to handle this case for generation. So let's get the child node. And if the child node is a type, and node.value equals size, which should be the only possibility at the moment, then we need to return, I guess it's the byte size. We'll return an immediate that is the byte size of the child node, the type node. Eight. 8 is the size of an i64. So if I go over like VIC4, that should be like 16. 16. Cool. All right. Nice. Poor old GLSL, I feel like gets left out a lot. Let's add support for this here. Actually, there's just so much stuff that doesn't work in GLSL. I think we're gonna have to do a big thing for that later. So let's not worry about GLSL right now. But yeah, I think I want to expand the test suite to cover a lot more stuff. And then I also want to find a way that I can run the test suite on GLSL code to make sure that in GLSL we're supporting everything we need to. I think that'd be my approach. So we're a bit over an hour, but I'm kind of tempted to do this one as well. Name. I feel like that's not going to be too hard to add. We've kind of done a lot of the heavy lifting already, so if we say name, then the data type we should get back is a string. And so now we need to create a string. I guess one way we could do it is we could create a literal, a string literal. I feel like a static variable would be better, but this will work. I'm going to put this here because I feel like maybe it should be a static variable, but so this will create a string literal with this value, but actually we want the child node. Well, we want the type name of the child node. So we need type checking, which we have. That's what the string should be, the type name of the child node. So then if we go big4.name, why are we don't need to I2A that. I'm kind of surprised that worked actually. This is an i64. How does that? Oh yeah. Oh no, so this one does need to be converted, this one does not. It's already a string. Okay. Confusing myself. Comma expected after operand. 533. 533. Well, this is our type name, but it's not in quotes. Okay. So let's do an a print if. Like so. So that should wrap it in quotes. All right, there's our type name, our size, and our type name. Cool. Max and min, you know, we're already at an hour 6. Do you think we can do max and min as well? Maybe max and min will take a bit more time because they, you know, we have to do it differently, probably for different types. We have to query it from, we have to find a way in Odin to get that information. I think we'll leave that for now. I wonder if there's like any like little bug fixes or or small things that we can do. I'm actually kind of tempted to do this because this is an annoying one. So if I go foo is, you know, the result of this. Print line does not have a return type. Oh, foo's already been declared. So let's go bar. Couldn't I determine type of bar? Has this been fixed? So print line does not have a return. So the left-hand side was none. The right-hand side after doing this, so that would be none, this would be nothing. Interesting. So if I go like this, if I just cut everything out, and where were we? Assignment. Yeah, we have this breakpoint. Let's find our thing. This is imports. There's probably going to be a bunch of stuff. Oh no, here we go. Didn't take too long. So I'm curious, what's the right-hand side node data type is dull. Left-hand side node data type is none. So now it gets overridden with null. So it just removes this none data type, which then triggers this. Could not determine type. Okay, so we do get an error message instead of crashing, which is great, better than it was before. But is it really a valid error message? I think actually we should say like, hey, this needs to have a type. I think we should in here say like, if that's nil. So if we need a data type for the left-hand side, but the right-hand side's not providing anything, then we'll have an error message, but something a bit different. And I guess it's actually the right-hand side node we're interested in. So maybe it's like a must return value from right-hand side. Does that make sense? So then we get it now, 1523. 1523. It's printing it right here. I'm not sure why it's there, but must return value from right-hand side. I feel like that's better. And the only reason that you would not have a type coming back from this is if it was just a call and the return had no return type. I think that's the only way. I think any other way, any other thing that you had here would have a type. So I think saying must return is a good message. Okay, yeah, surprised though that was kind of fixed up just randomly by other stuff. So we took those out. This does not crash, that's been fixed. And what was the main thing? It was like data type. So I want to do allocator and directive as well. I want them to be their own special nodes. Cool. All right. I'm happy. That was an hour 12. Not too bad. Thanks for stopping by. Have a good one. Ciao for now.